This is exam 1, test 1 review, business math, finite math, financial mathematics. This is additional review to your professor and instructor exam review. This is good review and tutorial for students in business math, finite math, financial mathematics, college algebra, high school algebra 1 and algebra 2. To prepare for development math algebra support, watch my college algebra exam 1 review and development math exam 1 review. I'm sharing this with you only as additional help in addition to your professor instructor exam test review, which should be your main essential review. This review is a complete review of chapter 3 and 4, functions, graph of functions, applications of linear functions, quadratic functions, polynomial functions, rational functions, exponential functions, applications of exponential functions, logarithm functions, logarithm and exponential equations. Also, this is it has a lot of good information if you are managing a business or planning to start a business. There is a lot of good information how to run a business. Okay, before we start, please subscribe, share and like, and ask your friends to subscribe, share and like. Thank you. My name is Osman Anwar. I have been professor of engineering and business mathematics in Dallas, Texas, USA. Please subscribe to my 4 education channels, share and like, and ask your friends to subscribe, share and like. Links are in the description. My 4 education channels are specifically for university and college students and high school students. Channel 1 is for business students. It has business calculus, business math, and mathematics of finance. Channel 2 is for engineering STEM students. It has Calculus 1, Calculus 2, and High School AP Calculus. Eventually, I will add Calculus 3, Differential Equation, Linear Algebra, and so on. My Channel 3 it has trigonometry and high school geometry. Channel 4 has college algebra, intermediate algebra, which is a development math, and high school algebra 1 and algebra 2. In all my channels, I have 3 plans. Plan number 1 is I have exam reviews and test reviews that I have solved with my students in classroom, and my students have used those exam reviews and test reviews to excel in my class. I will convert those exam reviews and test reviews into video presentations and share them with you. Plan number 2 is I have been solving many mathematics problems, business applications, engineering applications in classroom with my students. I will convert those detailed solutions into video presentations and share them with you. Plan number 3 is I will show you how to use technology such as Excel and graphic calculators, how to use technology to solve mathematics problems, business applications, and engineering applications. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like. Here are details of my plans. Plan number 1 is share with you video presentations of my exam reviews and test reviews. Plan number 2 is share with you video presentations of my detailed solution to examples and applications. Through my plans, you will learn how to succeed and get A in business calculus, how to succeed and get A in business math, how to succeed and get A in engineering calculus, how to succeed and get A in high school AP calculus, how to succeed and get A in trigonometry, how to succeed and get A in high school geometry, how to succeed and get A in college algebra, how to succeed and get A in intermediate algebra, which is development math, how to succeed and get A in high school algebra 1 and algebra 2. I will show you how to use technology to solve mathematics applications / problems, technologies such as Excel, graphic calculator, how to use technology to solve business math applications, engineering math applications, mathematics of finance applications, calculus derivatives and integrals, trigonometry, college algebra, intermediate algebra, development math, high school algebra 1 and algebra 2. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like, and thank you very much. Number 1 is domain of functions. States the domain of each function. So A is x to the 6 plus 2x to the 4 minus 1. This is a polynomial. Then all values of x are in the domain. That is, the domain is from negative infinity to infinity. That is all x values. B is square root of 9 plus 3x. So the domain for this, inside the radical you cannot have negative, so square root of negative is not valid, a real number. That means 9 plus 3x has to be greater or equal to 0. That is, 3x has to be greater or equal to minus 9. That is, x has to be greater or equal to minus 3. So the domain starts at minus 3 and it goes all the way to infinity. So it is from minus 3 to infinity, minus 3 included. Minus 3 will give you 0. Square root of 0 is 0. That's the starting point. C is x squared minus 6x plus 5 over x squared minus 64. And this one, you cannot have 0 in the denominator. 0 in the denominator makes this function undefined. That is, x squared minus 64 equals 0 is not acceptable. That is, x squared equals 64, then x is plus or minus 8. So the domain is all x except x cannot be plus or minus 8. If x is 8, 8 squared is 64, 64 minus 64 is 0. If x is minus 8, minus 8 squared is 64, 64 minus 64 is 0. So the domain is from negative infinity to minus 8, union minus 8 to 8, union 8 to infinity. that is all x except minus 8 and 8. Okay. Number 2 is function values. Find the value of the following function, which is piecewise function. So f of x is x squared plus 6 if x is less than 3. F of x is equal to 2x minus 3 if x is greater or equal to 3. Okay. So f5, so we need to identify where f5 belongs. So 5 is greater or equal to 3. That means f of 5, we're going to use f of x equals 2x minus 3. That is f of 5 is 2 times 5 minus 3 equals 7. F of minus 2, b is f of minus 2. Minus 2 is less than 3. That means f of x is x squared plus 6. That is f of minus 2 is minus 2 squared plus 6 equals 4 plus 6, which is equal to 10. Fc is f of 3.5. 3.5 is greater than 3. That means f of x is 2x minus 3. That is f 3.5 is 2 times 3.5 minus 3 equals 4. F of 0.1. 0.1 is less than 3. That means f of x is x squared plus 6. That is f of 0.1 is 0.1 squared plus 6 equals 0.01 plus 6, which is 6.01. Okay. I have several videos how to graph piecewise function using technology TI-84+. Please watch those videos. Number 3 is application, business application. The number of passengers in planet in millions for the year 2000 to 2011 can be approximated by the function f of x equals 0.377x to the 4 minus 9.23x to the third plus 71.4x squared minus 163x plus 666, where x0 corresponds to year 2000, that is the start point. Find the number of in-planet passengers in the following years. In 2000, x is 0, that's the starting point. F of 0 is you substitute every x by 0, so this is 0, then this is 0, this is 0, this is 0, that is f of 0 in 2000 it was 666 million. B in 2004, 2004 minus 2000 is 4, that is 4 years later. That is f of 4 is substitute every x by 4. So that is 4 to the 4, 4 to the third, 4 squared, 4. And that will give you 662.192 million. In 2000, C, 2009, 2009 minus 2000 is 9, then f of 9 is substitute every x by 9, then you will get 727.227 million. D in 2010, 2010 minus 2000 is 10, x is 10, f of 10 substitute every x by 10, then that will give you 716 million. Okay. Number 4 is graph of piecewise function. Graph the following piecewise function. F of x equals 2x minus 1 when x is less than 0. f of x is equal to -1 when x is greater or equal to 0. So first find the y-intercept. Y-intercept is simply f of 0, which is equal to y. So that is, when you substitute 0 here, it is -1. In the second one, always y is -1. So the y-intercept is -1. Then find the x-intercept. Then 2x minus 1 is equal to 0. X equals half. 2x equals 1, then x is to half. So that is not in the domain of 2x minus 1. So half is not in the domain. X has to be less than 0. That means x equals half is not included in the domain of 2x minus 1. That means no x-intercept. Okay. Again, I have several videos on how to graph piecewise function using technology TI-84+. Please watch those videos. In business, it is very important how to read the graph, learn how to read the graph. So that is, when you pick a newspaper or in the internet, when you Google, and if there is business information in graph format, you should be able to read it and understand it. Okay. So number 5 is graph reading application. Finance. The following graph shows the number of FDIC insured financial institution in the United States for the year 1990 through year 2010. Okay. So number A is this graph is this the graph of a function? If you run a vertical line test, everywhere the vertical line test crosses this graph only at one point. That means yes, this is a graph of a function. That is, for every value, for every input, there is one output. Okay. What does the domain represent? The domain is year 1990 to year 2010. Okay, that is a year. And estimate the range. The range is the y value. So you look at the graph. So the lowest point in the graph is between 8,000 and 9,000. No, between 7,000 and 8,000. That means you estimate here it is closer to 8,000. So your lowest point estimate is going to be 7,500, 7,600, 7,700. Those are all good estimates. 700, 800, and so on. So that's a very good estimate here. Then the upper end, it is between 15,000 and 16,000, and it looks like halfway. So 15,400, 15,500, 15,600, all those are good estimates. So those are an estimate. If you have the actual value, if you have the data in your hand, then just tell us. And it looks like they have the data, and they say that the lowest value is 7,750 and the highest value is 15,400. So those are the range. Okay. Number 6 is break-even analysis. Business. The revenue in millions of dollars for the sale of X million units at a Home Depot supply outlet is given by R of X equals 0.21x. The profit in millions of dollars from the sale of X unit is given as P of X equals 0.084x minus 1.5. A is find the cost function equation. So we know the revenue, we know the profit, then we know profit equals revenue minus cost. That means cost equals revenue minus profit. That is, it is 0.21x minus 0.084x minus 1.5. And that is 0.126x plus 1.5. That is a cost function. B is what is the cost of producing 7 million unit. Then simply plug 7 into the equation 0.126 times 7 plus 1.5, and that will give you $2.382 million. Okay, what is the break-even? The break-even is the revenue equals cost. When revenue equals cost, that is, it is when profit is 0. So break-even means you didn't make any money, but you didn't lose any money also. So you are at 0. The profit is completely 0. So when you set the profit equal to 0, 0.084x minus 1.5 equal to 0, that is 0.084x equals 1.5, divide both sides by 0.084, then that is x is equal to 17.857 million unit. So that is, when he makes 17.857 million units, then you break even. Break even means you do not lose any money, but you do not have any profit also. That is a break even. Okay. Number 7 is supply and demand equilibrium points analysis. This is economics. Let the supply and demand for a banana in cents per pound be given by supply P equals 0.4Q and demand is P equals minus 0.4Q plus 100. Find the equilibrium quantity. So the equilibrium quantity is, equilibrium is when supply equals demand. Supply equals demand means whatever is supplied by the supplier, the customer will buy all of them. That's why it means supply equals demand. That is P supply equals P demand means 0.4Q equals minus 0.4Q plus 100. Then when you move 0.4Q to the left, then that is 0.4Q plus 0.4Q, which is 0.8Q equals 100. Divide both sides by 0.8, then Q is 125 units, and that is the equilibrium quantity. This is the quantity that will be produced and consumed or bought by the customer. So find the equilibrium price. The equilibrium price, you can use either of the supply or demand function. So P equals 0.4Q, which is P equals 0.4 times 125, which is 50 cents. Even if you use the other P, you also will get minus 0.4 times 125 plus 100 will also give you 50 cents. So the equilibrium point is then when the price is 50 cents, the quantities are 125, and those are the equilibrium price and quantity. Now outside that, compare the quantity supplied and demand at the price of $1, which is 100 cents. If you set the price 100 cents, let's look what happened to the supplies. supply is equal to 100 plus 0.4 Q, then Q is equal to 250. So the supplier is willing to provide 250 bananas. And the demand is 100 minus 0.4 Q plus 100. 100 minus 100 is 0. Then Q is 0 over 0.4 minus 0.4, which is Q is 0. So that is when the price is set at 100 cents, although the supplier is willing to provide 250, but the customer is not willing to buy any banana because it is too expensive. It's twice of 50 cents. So here you have the supply there is a lot of supply, 250 bananas, but no one is willing to buy them. The customer buys nothing, 0. Okay? And that is why this is the supply and demand is very important in economics. You need to know how to set the price to make sure that the customer buys your product. Okay. Number 8 is graph of quadratic function. Graph the following quadratic function: g of x equals x minus 2 squared. So first find the y-intercept. Y-intercept is just g of 0, which is y equals 0 minus 2 squared, which is minus 2 squared equals 4. Okay. Then find the x-intercept. The x-intercept is g of x equal to 0, that is x minus 2 squared equal to 0. Take square root of both sides, x minus 2 equal to 0. That means x equals 2 is the x-intercept. Then find the vertex of this quadratic function. That is, the quadratic function in vertex form is a times x minus h squared plus k. And compare this to the given function. G of x, a is 1, x minus 2 squared, 2 is h, plus 0, 0 is k. So that means h is 2, k is 0, and that is your vertex. So your vertex is 2, 0. Then this is a parabola open up because you have a positive coefficient here. So you have the y-intercept, the x-intercept, and the vertex. Then simply it is a parabola open up. Okay. Number 9 is graph of polynomial function. Graph the following polynomial function. H of x equals x plus 3 times x minus 1 times x plus 1, which is x cubed minus 13x minus 12. We're going to graph this using end behavior. End behavior is we identify the end behavior of the graph just by looking at the function. Let me explain what end behavior is. End behavior of polynomial function is a polynomial function will open up if the leading term is even power. Even power means x squared, x to the 4, x to the 6, x to the 8, x to the 10, and so on. So it will open up if the leading coefficient is positive, that is 4x squared, 2x to the 4, and so on. And it will open down if the leading coefficient is negative, for example, minus 3x to the 6 plus 5x minus 5x to the 10, and so on. Then if the leading term is odd power means x cubed, x to the 5, x to the 7, x to the 9, x to the 11, and those are odd powers. So if the leading term is odd power and its coefficient is positive, for example 5x to the 7, 3x to the 6 to the 5, and so on. In that case it is odd power, and with a positive coefficient, then it will increase from left to right. And if it is odd power and its coefficient is negative, for example minus 6x to the 9, then it will decrease from left to right. So now by looking at this, the power, the degree is 3, that means it is odd, and you have positive coefficient, it is 1, that means this is the end behavior of this is increases from left to right. So it will increase from left to right, that means it is C. Okay? Then identify the x-intercepts. It is x cubed, so it will have 3 or less x-intercepts, and the vertex will be 2 or less. Vertex means the turning points, which is the highest point and the lowest point. It is 2 or less. Okay? So now to graph it, so first find the y-intercept, which is h of 0, which is y equals 0 plus 3 times 0 minus 4 times 0 plus 1, which is minus 12. Okay? Then find the x-intercept. The x-intercept is h of x equal to 0, which is x plus 3 times x minus 4 times x plus 1 equal to 0. That is x equals minus 3, x equals minus 1, and x equals 4 are the x-intercepts. So now the vertex, the turning points, at this point we don't know what they are. Once you get to calculus class, you will learn how to take derivative, set it equal to 0 to find the maximum and the minimum point. But right now we're going to use this analysis to graph it. So to graph this, so the first thing is we graph the end behavior. The end is this point, this line. That means that is this line. So x equals minus 3 is the x-intercept to the left. Then from minus 3 to infinity, it is this graph. Okay? Then that is the left end. The right end is, it is x equals 4 is the x-intercept to the right, and that is the right end is this, so it is this point. Then in between is this, between these two endpoints. So to graph this, so we know it is going to cross at x equals minus 3, so cross it, so go up. Then at some point you have to turn down because it has to cross x at minus 1. So go up, then turn down, then at x equals minus 1 you cross it, then keep going down. It will cross it also at y equals minus 12, then keep going down. Then at some point you have to turn back, and that is you have to cross the x-axis at 4. And that's how you graph using this end behavior analysis. So in calculus, as I said, you will learn how to take derivative and set it equal to 0 to find this maximum point and this minimum point. Okay. Number 10 is graph of rational function. Graph the following rational function: f of x equals 3x plus 2 over 2x plus 4. So first find the y-intercept, which is f of 0 equals 3 times 0 plus 2 over 2 times 0 plus 4, which is 0 plus 2 over 0 plus 4, which is 2 over 4 equals half. So that's the x-intercept, okay? The y-intercept. Then also find the x-intercept. The x-intercept is f of x equal to 0. That is, set the numerator equal to 0. That is 3x plus 2 equal to 0. That is 3x equals minus 2. That is x equals minus 2 over 3. And that is your x-intercept. Then find the vertical asymptote. The vertical asymptote is set the denominator equal to 0, which is 2x plus 4 equal to 0. That is 2x equals minus 4, x equals minus 2. That is your vertical asymptote. Okay, the blue line. Then find the horizontal asymptote. You look at the rational function and you look at the highest x term, which is in this case it is 3x on the numerator and 2x on the denominator. Then it is simply they are equal, the power are the same. That means the coefficient of x over coefficient of x in the numerator and denominator, that is your horizontal asymptote, which is 3 over 2. And that is the green line. Then simply put the points. So you have the x-intercept, the y-intercept. Then as x goes to infinity, this is equal to the horizontal asymptote. And as x goes to approaches minus 2, it goes to the vertical asymptote, which is to infinity. Then here also, as x approaches to infinity, it is a horizontal asymptote, the horizontal asymptote, which is 3 over 2. And that is the graph. Okay. So this number 11 is cost-benefit function. Suppose a cost-benefit model is given by the following rational function: f of x equals 4.3 x over 100 minus x, where f of x is the cost in thousands of dollars of removing x% of a given pollutants. Find the cost of removing each of the given percent of pollution. So that is, if you want to remove 80% of pollution from your product, that is 4.3 times 80 over 100 minus 80 times 1,000. That will cost you 17,200. Okay. Then if you want to remove 90% of the pollution, then that is going to cost you 38,700. If you want to remove 95% of the pollution, it will cost you 81,700. Notice how it is growing very fast. So removing 80% cost is 17,000, but removing another 10% will cost you twice, more than twice, 38,000. But removing 95% will cost you 81,000, which is very big jump here. Then removing 98% of the pollution will cost you 210,000, and removing 99% of the pollution, it will cost you 425,000. So this is very important analysis, because if you are running a business, so if you remove only 90% of the pollution, although it costs you 38,700, but probably nobody is going to buy your product, then you will just be losing 38,000, because it is not 10% of the pollution is not good. Okay, but if you remove 95%, most customers will not buy your product because 5% pollution is too much. Okay, also you have to consider the competition. The competition probably has more money than you and can remove 99% of the pollution at 425,700. Okay, so that is when you remove, so from 98% to 99, it is only 1% difference, but look at the cost. The cost is 210 for 98%, but 99% is 425,000. So now if you want to remove more, so at 99, probably you will be able to run a business. Probably your customers might be interested in your product, but there is a competition that will remove more pollution than it is more better product. For example, if somebody is willing to remove 99.9, so that will cost the company 4,295,700, but this is probably big corporation can afford removing, spending this much money, removing 99.9%. But now removing 99.99, which is very small difference between 0.9 and 0.99 is 0.01, which is extremely small percent difference, but that will cost you 42,995,700. So now even big corporation might not be willing to spend this much money to remove additional, just to remove 0.01%, that is more. Okay, then if you want to make it close to 100, for example, removing 99.9999, that will cost you 4,299,795,700, and that is probably no. So this is too much. Even big corporation will not spend this money to remove, to make it almost 100% pure. How about if you want to make it 100% pure? Then that does not exist. You cannot do anything. You cannot spend the whole money in the world to make it 100% pure. So that is, if you plug this in the calculator will crash. And it is obviously 100 minus 100 is 0. So no matter what is in the numerator, the denominator is 0. That means this does not exist infinity. So this is business analysis, cost benefit analysis that you need to run. You need to consider to run a business. It doesn't have to be pollution. It could be any other cost benefit analysis. And number 12 is product exchange function. the product exchange function of gasoline X and hidden oil Y in hundreds of gallons per day is shown. Y equals 125,000 minus 25x over 125 plus 2x. So estimate the maximum quantity of gasoline X that can be produced. So if you want to produce the maximum gasoline X, then you will not produce any hidden oil, which is Y is 0. Then simply set the numerator equal to 0. 125,000 minus 25x equals 0. X equals 5,000. That is maximum X. That is the x-intercept. Then if you want to estimate the maximum quantity of hidden oil Y that can be produced, and that is you will not produce any gasoline. That means it is a y-intercept. Then it's just set x equal to 0. Y equals x is 0, so it's 125,000 over 125. Y equals 1,000. So this is x equals 5,000 is the maximum gasoline you can produce, and y equals 1,000 is the maximum hidden oil you can produce. Now if you want to mix, you want to produce some gasoline and some hidden oil, so let's say you want to produce 215 of gasoline, which is x, then just plug x equals 215 into the equation. That will give you y equals 215.54. That means you can produce 215 of gasoline and 215 of oil, which is half-half. Okay, and this is product exchange function, which is it is important in business to decide which one to how much to produce of each. Number 13 is graph of exponential function, and we're going to use translation or transformation to graph this. So let f of x equals 3 to the minus x, or f of x equals minus 3 to the minus x, which is it is a reflection of this in the y-axis. Then shift them, then translate them. So graph A is f of x equals 3 to the minus x plus 1. So it is 3 to the minus x shifted up by 1, which is a blue graph. Then graph the exponential function f of x equals 3 to the minus x plus 1. Set x plus 1 equal to 0. That is x equals minus 1. That means shift to the left by minus 1. So it is 3 to the minus x shifted to the left by minus 1, which is the red graph. Then C is graph exponential function f of x equals minus 3 to the minus x minus 1, and that is it is minus 3 to the power of minus x. Minus 1 means shifted down by 1. That means it is this yellow graph which is shifted down. It is reflected on the x-axis and shifted down. Then graph exponential function f of x equals minus 3 to the power of minus x plus 1. So set x plus 1 equal to 0, x equals minus 1, then this is minus 3x to minus 3 to the minus x. It is shifted to the left by minus 1. So this is graph of exponential function using translation or transformation. Number 14 is application of exponential function. The amount in megawatt of energy generated in the United States from wind power can be modeled by the function Wt equals 2540 times 1.3 to the power of t, where t equals 0 corresponds to 2000. Estimate the amount of energy generated by wind power in the years 2000. 2000 is t is 0, that is w 0. So this is 2540 times 1.3 to the power of 0. Anything to the power of 0 is 1, then this is 2540 megawatt. In 2000, B is 2005. 2005 minus 2000 is T is 5. Then W5 is 2540 times 1.3 to the 5. And that gives you 9431 megawatt. C is in 2012. 2012 minus 2000, T is 12. Then W12 is 2540 times 1.3 to the power of 12, which gives you 59,177 megawatt. Then if the model continues to be accurate, project the amount for the year 2018. 2018 minus 2000 is T is 18. Then W18 is 2540 times 1.3 to the 18, which is 285,637 megawatt. So this is amount of energy generated in the United States from wind power in 2000, in year 2000, in year 2005, 2012, then 2018, which starts at 2000 and it increases to 9,000, then it went up to 59,000, then it went up to 285,000, which is a lot of increase. Okay, number 15 is logarithm function. Without using a calculator, evaluate the following logarithm expression. So we're going to use this identity of log. Log a to the n is equal to n log a. So we're going to use that for all of them. For a, it is log 0.000001. And that is log 10 to the minus 7. So move this decimal 1, 2, 3, 4, 5, 6, 7. So that is log 10 to the minus 7. Then this is equal to minus 7 log 10. Log without base means log base 10. So log 10 is 1, then this is minus 7 times 1, which is minus 7. Log base 3 is 729, and that is, if you divide 729 by 3 6 times, it will be this 729 will be 3 times 3 times 3 times 3, 6 times. That is 3 to the 6. Then this is equal to 6 log base 3. Log base 3 is 1. That is 6 times 1 is 6. This is log base 4 of 1 over 4096. So this is log, if you take 4096 divided by 4, 6 times, it will become 4 times 4 times 4 times 4, 6 times, that is 4 to the 6. Then you can rewrite this as log base 4, 4 to the minus 6. Then that is minus 6 log 4 base 4. That is 1. Then this is equal to minus 6. Log base 6, 1296. Divide this by 6. When you divide it 4 times, it will become 6 times 6 times 6 times 6. That is log base 6, 6 to the 4. That is equal to 4 log base 6 of 6, which is 1. Then that is equal to 4. This is ln of 1 over cubic root of e to the 5. This can be written as ln cubic root of e to the 5 to the minus 1. This is also can be written as ln e to the 5 to the minus 1 over 3. And this is equal to ln e to the minus 5 over 3. Then this is equal to minus 5 over 3 ln e. Ln e is 1. Then this is minus 5 over 3. This is apply product, quotient, and power property to solve the following logarithmic expression. So express as a single expression. So you have two expressions of log here. 5 ln 5x minus 3 plus 7 ln 3x minus 1. So to express this as a single log, we're going to apply this. ln AB is ln A plus ln B. ln A to the n is n ln A. So first we need to bring this power up here. So this becomes ln 5x minus 3 to the 5. And this becomes ln 3x minus 1 to the 7. Now we have ln A plus ln B, which is ln AB. So then this becomes ln 5x minus 3 to the 5 times 3x minus 1 to the 7. That is ln A times B, which is this property. Okay. B is expressed as a single expression. Again, we're going to take, this is 2 log 2x minus 5 minus 3 log x plus 10. So to take this and make it 1 log, so you take the 2 and bring it up here as a power and bring the 3 to the power. So this is log 2x minus 5 to the second minus log x plus 10 to the third. Now it is log A minus log B, and that is, we're going to use this log A over B is log A minus log B is log A over B. That is equal to log 2x minus 5 squared over x plus 10 to the third. Okay. The number C is expressed as a sum and or difference. So you have now 1 log. We're going to break this into several log. So this can be written log square root of 81 y to the 6 z to the 8 can be written as log 81 y to the 6 z to the 8 to the half. Then you can bring this half down here. Then this becomes log 81 is 9 squared y to the 6 z to the 8. Then you can break this. This is log A B C. Then you can write this as log 9 squared plus log y to the 6 plus log z to the 8. Then you can also bring the 2 down. Then this is 2 log 9 plus 6 log y plus 8 log z. then divide everything by 2, then this is log 9 plus 3 log y plus 4 log z. Number 17 is an application of logarithm function. It is economics. The median family income is the middle income. Half the families have this income or more, and half have less income. The median income family income can be approximated by f of x equals 22,751 plus 8,217 ln x plus 1. So where x0 corresponds to year 1990, this is the start. What is the median income in the following years? In 2090, that is x is 0, then f of 0 is 22,750 plus 8,217 ln 0 plus 1. Ln 1 is 0, then this is simply 22,751. In 2000, b is in 2000 minus 1990 is x is 10, so f of 10, then that is going to give you 42,454. Then in year C, in year 2010, which is 2010 minus 1990, that is x equals 20, then that is going to give you 47,767. So now you see in 2000, if the in 2000 it was 22,000, in 1990 it was 22,000, then it increased to 42,000 10 years later, then another 10 years later it increased to 47,000. Not much increase here in 10 years. Then, if the model remains accurate, when will the median income reaches 52,000? And that is 52,000 equals 22,751 plus 88,217 ln x plus 1. That means 8,217 ln x plus 1 is equal to 52,000 minus 22,751, which is 29,249. Then divide both sides by 8,217. That gives you 29,249 over 8,217. Then take e to the both sides, that e to the ln x plus 1 is just x plus 1. Then e to the power 29,249 over 8,217. Then x is simply this, e to the 29,249 over 8,217 minus 1. Then that is x equals 34.148. That is, x is about 34 years later, the median income will reach 52,000. That will be year 2024, because it is 34 plus the beginning was 1990. So that is in year 2024, the median income family will reach 52,000. Okay. 18 is solve logarithm equation. Solve the following logarithm equation. A, ln 3x plus 1 minus ln 5 plus x equals ln 2. So this is ln a minus ln b, which is ln a over b. That is ln 3x plus 1 over 5 plus x equals ln2. So this is the same base e. Ln is base e. That is therefore 3x plus 1 over 5 plus x is equal to 2. So it's the same base. So that is 3x plus 1 is equal to 2 times 5 plus x, which is 3x plus 1 equals 10 plus 2x. That is 3x minus 2x equals 10 minus 1. That is x equals 9. Okay. If you want to check, then put 9 here. So this is 3 times 9 is 27. 27 plus 1 is 28. Then at the here it is 5 plus 9 is 14. So 28 divided by 14 is 2. That is ln2 equals ln2. B is log base 3y plus 2 equals log base 3y minus 7 plus log base 3 4. So if we take this log base 3y minus 7 to the left, then this becomes log base 3y plus 2 minus log base 3y minus 7 equals log base 3 4. And this is log a minus log b, which is log a over b, which is log base 3y plus 2 over y minus 7 equals log base 3 4. So you have the same log base 3, the same log base 3. Therefore, y plus 2 over y minus 7 is equal to 4. That is y plus 2 is equal to 4 times y minus 7. That is y plus 2 equals 4y minus 28. Then 4y minus y equals 28 plus 2. Then 3y equals 30, y equals 10. So to double check, take 10 and put it here. Y plus 10 plus 2 is 12. Then 10 minus 7 is 3. Then 12 divided by 3 is 4. Log base 10, which is just log 3 plus b equals log base 10 4c minus 1, and we want to solve for c. They are the same base. That means 3 plus b is equals 4c minus 1. That is 4c is equal to 3 plus b plus 1. That is 4c equals 4 plus b. That is c equals 1 plus b over 4, or c equals 4 plus b over 4. Number D is log base 7 r plus 3 plus log base 7 r minus 3 equals 1. So now they are not, the left and the right are not at the same base. Then the left, it is log a plus b, log b, that is log a times b, that is log base 7 r plus 3 times r minus 3 equals 1. Then you can take this 7 and raise it to the 1. So it's 7 to the 1. Then you can cancel the log. Then this is r plus 3 times r minus 3 equals 7 to the 1. Okay, that is r squared minus 9 is equal to 7 to the 1 is 7. That is r squared is 9 plus 7, which is r squared equals 16. R equals plus or minus 4. Then r is equal to 4 will work, but r equals minus 4 is not in the answer, because r minus 4 will give you here minus 1. Log of minus 1 is not defined. R of minus 4 minus 3 is minus 7. Log of minus 7 is not defined. That means only the positive r equals 4 is the answer. Okay. 19 is solve exponential function equation. Solve the following exponential equations without using log. for A, that is 25 to the power of minus 3x equals 3125. If you break this 3125 divided it by 5, when you divided it 5 times by 5, it's going to be 5 times 5 times 5, so this is 5 to the 5. And 25 is 5 squared, that is 5 squared 2 times minus 3x. That means 5 to the minus 6x equals 5 to the 5. The base are the same, 5, 5. That means minus 6x is equal to 5. That is x equals minus 5 over 6. Then B is, you're going to use logarithm function to solve 4 to the x plus 2 equals 5 to the x minus 1. So take natural log of both sides, that is ln 4x plus 2 equals ln 5x minus 1. Then using the property of logarithm, you can take the x plus 2 down. That means it is x plus 2 times ln 4. Also on the right it is x minus 1 ln 5. Then this is distributed x ln 4 plus 2 ln 4 equals x ln 5 minus ln 5. Then this is take all the x's to the left, then x ln 5 minus to the right x ln 5 minus x ln 4 equals 2 ln 4 plus ln 5. Then factor out x ln 5 minus ln 4 equals 2 ln 4 plus ln 5. Then divide both sides by ln 5 minus ln 4. Then x is 2 ln 4 plus ln 5 over ln 5 minus ln 4. That is x equals 19.6377. Okay. Number C is use logarithm to solve 10 to the power of 4c minus 3 equals d. Then take log base 10 of both sides. This is log base 10, 10 to the power of 4c minus 3 equals log base 10 of d. Then you can take the 4c minus 3 down, so this is 4c minus 3 log 10 equals log d. So log 10 we know it is 1, so this is 4c minus 3 times 1 equals log d. That is 4c equals 3 plus log d. That is c equals 3 plus log d over 4. That's the answer. This is an application. The percentage of US income earned by the top 1% of earners can be approximated by the function f of x equals 7.9 e to the 0.0254x, where x equals 0 corresponds to the year 1990. Okay. Now to the question is find when did the percentage reach 15%. If the model continues accurate, when will the percentage reach 30%, which is the y? So now to do that, first let's find the general solution. F of x is equal to 7.9 e to the power 0.254x. So f of x is y, then y is equal to 7.9 e to the power 0.254x. So that is e to the power 0.254x is equal to y over 7.9. Then now take natural log of both sides. ln of e to the power 0.0254x is equal to ln of y over 7.9. That is 0.0254x is ln e is equal to ln y over 7.9. ln e is 1, then 0.0254x times 1 is equal to ln y over 7.9. Then minus x is ln y over 7.9 over 0.0254. Now you can easily answer B. B is y is 15%, then simply plug for y equals 15, then x is ln 15 over 7.9 over 0.0254, which is x equals 25.24, that is 25 years later. That is, the year is, the beginning was 1970, 1970 plus 25, that is year 1995. Then if the model remains accurate, when will the percentage reach 30%, that is y is 30%, then simply substitute for y30, that is ln 30 over 7.9 over 0.0254. That is x equals 52.53. That is year 52 years later. That is year 1970 plus 52, which is year 2022. Once again, please subscribe, share, and like, and ask your friends to subscribe, share, and like, and thank you.